Hello everyone, and welcome back to our channel. Today we're going to talk about Docker third-party images. So what is it so interesting about images that we pull from the Docker Hub or other registries that aren't maintained by Docker themselves? That's exactly what we'll be exploring today. First things first, what exactly are third-party images? Well, when you're working with Docker, you have the option to create your own images or use images that others have already created and shared. These shared images are what we call third-party images. They're created and maintained by the community or other organizations, not directly by Docker themselves. Let's say, for example, we want to pull the NGINX image from the Docker Hub. Searching for third-party images in Docker Hub is a crucial step in leveraging the vast repository of container images available. So how do we do this? We simply search for NGINX on Docker Hub, like this, or we could use the docker pull command in our terminal, followed by the name of the image, which in this case will be NGINX. And if we press enter, we can see that the pull has started using the default tag of the latest image. Docker will then fetch this latest image of the NGINX from the Docker Hub directly itself and store it, as we can see, on our local machine. If you run docker images command, you will be able to see in here that the NGINX image with the latest tag has been downloaded on our local machine, and we can also see other details such as image ID, when it was created, and also the size of the image. Another example that we could use is perhaps a different Docker image such as Node.js. So let's say you need to use this image for your project. You can easily initiate a search on Docker Hub by repeating the same steps. So Node and enter. In here, we'll be able to see quick references related to the image itself, supported tags and respective Dockerfile links. And if we scroll all the way through, you can see also additional references used and explanation as well what this image is. If we go back to our terminal, you can also do docker search node, and it will also list you all the possible versions and explanation descriptions included as well. So if you would like to pull this image as we previously did with NGINX, you just need to repeat the same steps. So that will be node, and then we can specify also latest or any other tags that you can find in here that are currently supported. Lastly, incorporating a third-party image directly in your Docker file is pretty straightforward. You can utilize the image name as the base image by employing the from directive, as you can see in this example here. This snippet establishes the Node.js image tagged with version 21 as the foundation of our Docker file. From there, we can proceed with defining additional instructions in order to customize and configure our container environments as per our need. Now, I would like us to explore how to find, pull and run Docker images for popular databases such as MySQL, PostgreSQL, and MongoDB using the Docker CLI. When it comes to databases, Docker provides a huge amount of images, making it convenient to set up and manage various database systems within containers. So first things first, we'll kick off with an example of MySQL. To search for a MySQL image on Docker Hub, you can use the following options, such as MySQL. And over here, we'll be able to see a list of MySQL related images available on Docker Hub itself, including this official image and of course the ones that are being maintained by the community. You can also do the same in the terminal by typing docker search MySQL. And as you can see here as well, if we extend it a little bit for clarity, we can also see the name for the images, also their description and other details included as well. Once you found the image you want to use, you can pull it to your local machine using the docker pull MySQL latest tag command. You could also replace the latest with the specific version tag if you want to pull a particular version of MySQL for the testing purposes. Once the download is completed, we will run the MySQL inside a Docker container. So we'll run a following command to be able to execute this from our local machine. So I'll just give it a moment or two for this download to complete. Perfect. And if we clear up the screen and do Docker images once again, we'll be able to see our MySQL with the latest tag, image ID, and also created date and size as well displayed here. Now to run MySQL in the Docker container, we will run docker run -- name, and we'll call it head in the clouds MySQL. And we will also specify the variables. So if you scroll down in here, we will also be able to see the environments that we need to put in place. So we will add MySQL root password, which we can copy from here. And we'll set that to, let's say, head in the cloud secret password. And we'll also specify the port number 3306. We can use the same for that, which is specific to the MySQL port number, which is dedicated for that. And we'll also, let's say, run in detach mode, and we'll be using this image. Perfect. We can see that it's been executed successfully. So let's do docker ps, and in here we can see that our Docker container is now up and running for about a few seconds. And also we can see the image that's been used on desired ports that we specified previously, and also the name of the Docker container. Now we can also look at another example, so PostgreSQL. So if we go to the Docker Hub and search for that, we can see the Postgres in here. We can also extend and see more details such as supported tags and other references to this particular image, also what commands you'll be able to run and what you could potentially specify, like we did in the MySQL, to be able to set the password. and so on, in case you would like to run Docker Compose, etc. So if you scroll all the way back, we will, just for the demonstrational purposes, also search for that in our terminal. And as you can see in here, if we extend it, you'll also be able to find a vast amount of information on this particular image. And let's clear up our screen, and we will use, let's list Docker pull Postgres and then do latest. And we'll complete the same process. We can either do it this way to pull the image to our local machine, or we can directly run the docker run command to be able to run the Postgres inside our container. And as we don't have the image pulled just yet, it will do it automatically for us. So let's do docker run, and then we'll specify the name again, head in the clouds, Postgres, and then we will set the password to head in the clouds secret password, and then we'll specify to use a port 5432, which is for Postgres, and we'll run in detached mode using the previously downloaded image. Once again, it's been successfully executed. We can also see it 3 seconds ago, initiated with the container ID image, and also specified ports that we described earlier, and of course the name of the container as well. Lastly, let's discuss MongoDB for demonstrational purposes. So to be able to search for that, as you can see, is fairly easy. You can do MongoDB as well in Docker Hub, and you'll also be able to see the list of available images here. You can also navigate through some of these filters if you're interested in specific products, let's say like images or extensions or plugins. You can also filter out the just to be able to see the Docker official image, so images being maintained officially by the Docker itself, and also some verified publishers. So definitely recommend to do a little bit of research in your free time as well. In this, you can also navigate through different operating systems as well as the architecture, as well as you can see below. And going back to the terminal, we will go straight into running the MongoDB in Docker container. So we'll use Docker run command, as that will automatically download the Docker image for that. We'll call it head in the clouds Mongo, and we'll specify the ports of 27017 on both host and the container, and we'll run in detached with this image. As you can see, it's unable to find the image locally, and it started the download, so pulling it from the library Mongo. And as you can see, it takes probably a few seconds to a minute to complete the download on our machine. We'll just wait for it to finish. And there it is. We've got our newer image downloaded for Mongo latest. And if we do once again Docker PS, we can see it here listed at the top, initiated a few seconds ago. And also we can see the specified ports, the name of the container, and also the image that we're been using as part of this exercise. So as you can see in here, we have 3 different examples of the databases: MySQL, Postgres, and MongoDB as well. As we just saw, Docker Hub serves as the primary hub for both official and community maintained images, offering a wide range of options for various technologies and applications. Now, while using third-party images can be incredibly convenient, there are a few things to keep on our mind. Since these images are created by various individuals or organizations, the level of trustworthiness and quality can vary. So here's a quick list to consider when evaluating third-party images. Popularity. We highly recommend you to check how popular the image is within the Docker community. As you can see, the higher popularity often indicates a more reliable image with frequent updates and community support. Maintainer. Look into the details such as who maintains the actual image. Is it a well-known organization or individual with a good track record? Or is it someone perhaps less established? Security. Security should always be our top priority. Therefore, checking if the image has any known vulnerabilities or security issues is a must. You can use tools such as Docker security scanning to help you with this. Documentation. Good documentation is key to understanding how to use an image effectively. Make sure the image you're considering has clear and comprehensive documentation available. By being mindful of these factors, you can make more informed decisions when choosing third-party images for your Docker projects. Additionally, if you're using third-party images in production environments, consider regularly updating them to ensure you're benefiting from the latest features and security patches. Now, let's talk about maintaining your Docker images. When utilizing third-party images, it's not a one-time affair. It's crucial to keep them updated, to integrate the latest security patches, bug fixes, and dependency changes. Regularly checking for updates in your base image is essential. This involves monitoring for new version releases by the image maintainers or upstream providers. This practice reduces the risk of security breaches and ensures the stability and reliability of your applications. Docker images aren't limited to just application stacks. They can also include command line utilities or standalone applications, making them incredibly versatile and convenient to work with. One such example is BUSYBOX, a compact and straightforward command line application that encompasses a wide range of commonly used Unix utilities such as awk, grep, vi, and more. To run BUSYBOX inside a Docker container, it's as simple as pulling the image and initiating it with Docker itself. So once again, we'll do Docker search and then do BUSYBOX. In here, we'll be able to see the name of the image as well as the brief description, stars given to this image, and also confirmation it's been a Docker official image itself. So let's clear up our screen and we will run Docker images. In here, we can't see BUSYBOX just yet, so we will do Docker pull BUSYBOX, and we'll go through the same process again of downloading the image. Once that's ready, we'll do Docker run using the interactive mode and specifying the image name and also bin shell. And once inside the container, you have the access to BUSYBOX utilities, just like you would have on any other regular command line. Another essential command line tool is curl, widely utilized for transferring data via various networking protocols. To incorporate curl into a Docker container, you can utilize the official curl image from Docker Hub itself. Once again, we will search for curl, and in here, we'll be able to see the name at the top of the list, a brief description once again, and also, as previously mentioned, the highest ranking at the moment. It has this image at the top of the page, which is curl images /curl. We will copy that, clear up our screen, and we will run docker pull and paste in here the curl images /curl. The download process will begin, and we'll check once again our image. We can see it here being downloaded on our local machine, and then we will do run. We'll specify remove to automatically remove this container once it exits it, and we'll paste in, apologies for this, the name of the image, which is curl images with the /curl. And let's say we want to curl a website such as google.com. And in here, obviously, you can see the return from the command itself. So basically, it will offer us the wide variety of command line utilities that we can use in order to troubleshoot or use any specific activities that we might need to undertake as part of this exercise. Perfect. If we do docker ps once again, we'll no longer be able to see our container here because of the -- remove flag, which is specifically dedicated to remove the container after executing the command, ensuring we're doing a cleanup once a task is being completed. Beyond BUSYBOX and curl, Docker offers another tools. Some of them noteworthy examples include wget, which is again a pretty handy tool to be aware of for non-interactive file downloads from the web, let's say. Also there's JQ, which is just a command line JSON processor, and ImageMagick, a software suite for image manipulation and conversion, in case you're also interested in that. And yeah, lastly, to utilize, of course, any of these tools, simply search for them on Docker Hub, and also follow the instructions provided in their respective repositories. Docker provides a fantastic solution for setting up isolated, disposable environments tailored for testing purposes. These environments can be easily created, utilized, and discarded once the testing phase is completed, eliminating any concerns about damaging your local setup and so on. To illustrate the process, let's use Python as an example. So we'll utilize a publicly available Python image from Docker Hub to set up an interactive test environment. So to initiate the environments with using the Python image, we will search for the image once again to get into habits. As we can see here, once again at the top of the page, the recommended image to use based on the stars, and also ensuring it's been provided officially by Docker itself. And we will then do the docker pull Python. Or we can directly just run the Docker container with the docker run command, and it will automatically pull the image for us if it's not already there. So docker run interactive mode with a remove option as well, and then we'll specify Python. And here it is. As you can see, you're now in the Python environments. Again, you can use it for testing purposes, as you'll be able to find yourself inside of an interactive Python shell within the container, where you can just simply play around and execute Python commands or install any additional packages using pip as usual. For this demonstration, we can just do print, let's say hello, head in the clouds, and enter. And we can see obviously here the message. Once you're finished with your interactive session, you can simply type exit and brackets, or just press Ctrl-D to exit a container. The container itself will be automatically removed as we specified the -- remove flag in here. So if we do docker ps, the Python container is no longer going to be there. Docker facilitates the creation of various other interactive environments for different software. Some other examples that you could use is, for example, Node.js. So Docker search Node. Again, in here, we'll probably choose the top one and do docker run it -- remove Node. And as you can see, we already have the image pulled down locally, so it just took us straight into the Node container. We'll exit that and do the same, let's say, for Ruby. So docker search Ruby, and we'll choose the top one. So docker run it remove Ruby, and it's currently downloading the latest image for us. Once that's completed, it will automatically start the Ruby container with the interactive shell, as we can see it in here. So yeah, to conclude with Docker, you can freely explore and test various software without worrying about damaging your local machine, which comes in pretty handy, or installing unnecessary dependencies on your computer. And getting this obviously into practice, using Docker for interactive test environments really does enhance efficiency and cleanliness when dealing with third-party software. And that wraps up our introduction to Docker third-party images. We hope you found this video helpful. If you did, please don't forget to give it a thumbs up and subscribe to our channel for more useful content. In our next video, we'll be covering container registries, what exactly they are, where you can store and manage your Docker container images. Until then, thank you for watching us and happy containerizing.